Hello, I'm Rohit. So today I am presenting a capstone project on speech emotion recognition using deep learning and ML project. Then contents of our model or project: introduction, problem statement, data summary, dependency analysis of data, data augmentation, confusion matrix, loss accuracy plot, challenges, and conclusion. Then introduction. Basically, the three main questions. Are three main questions. First, what is a speech emotion recognition? Basically, speech emotion recognition, abbreviated as a SCR, is act as a attempting the recognize the human emotion and effective state from speech. This is used on the fact of voice, often reflect the underlying the emotion through tone and pitch. This is also phenomena that animal like dogs and horse employ the able to understand the human emotion. SCR is a thought because emotion are subject to an antoning audio in challenges. Then why the speech emotion recognition is most important? Um, because emotion play an external important role in human mental life. It is a medium of expression of one's perspective of one's mental state uh, mental state to other speech of emotion state of the speaker from his or her signal. There are the few universal emotion including neutral, angry, happiness, neutral, angry, happiness, sad, disgust, in which any for each speech recognition because of this feature contain the emotion information. MLE frequency spectral coefficient MFCC is one of the spectral feature fundamental frequency, loudness, pitch, and speech intensity of glottal parameter are the parasite feature which are used to model the different emotions. What is the scope of emotion recognition? Uh, Basically, speech emotion recognition is a system through which the various audio speeches file are classified into different emotions such as happy, sad, angry, and neutral, disgust, and etc. Then move towards the problem statement. As a human being, speech is almost the natural way to express the ourselves. We depend so much on it that we recognize it is important when they're restoring the other communication from like email and text message, where we often use the emojis to express the emotion associated with the messages, as the emotion play the vital role and the communication. The detection and analysis of the same is a vital importance in today's digital world of the remote communication. Basically, the emotion detection is a challenging task because the emotion are subjective. We define the SCR system as a collection of the methodology that process and classify the speech signal to detect the emotion embedded in them. Then data summary. Uh, uh, in this portion of Riaz run, then let's move toward the data summary. This portion of Ryerson Audio Visuals database of the emotion, speech, and song, Revit days, contain the 1440 files, having 60 trials per actor, uh, having the Revit containing the 24 professional actors, 12 females and 12 males. The Localizing the lexical match statement is a neutral North American accent. Speech emotion include the claim, happy, sad, angry, fearful, surprise, and disgust expression. Each expression are produced at the two level of emotion intensity, normal and strong, with the addition of neutral. These are the wave file we can upload in our model, and we can collect the data from the Kaggle. These are this link of our data set. Then dependency. There are the most there are the most important library are used in our model for building our model. Basically, the first is NumPy, Pandas, Matplotlib, Pillows, Librosa, Streamlit, TensorFlow, CPU, Keras. Then let's move toward the ADO portion. The analysis of data is between emotion and count, uh, which contain the 24 professional actor, 12 female and 12 male. Uh, in this sample audio wave, after implementing the graph, we see that the all emotion like male happy, male angry, male sadness, neutral, and other, etc. And also the female happy, female sad. But after analyzing the data, the male neutral and female neutral data are comparing to other data is the half up than other data, means 50%, 50% than other data, having male fear and female fear like, and male happy and female happy. Then move towards the male spectrogram and male neutral. The graph is between the frequency and time. Basically, uh, basically, uh, basically the representation of an audio signal having the different emotion exhibited different pattern in the energy spectrum. Spectrogram is representation of an audio signal on a main scale. The logarithmic form of male spectrum helps to understand the emotion better because the human precisely sound and the logarithmic sound, therefore the spectrogram. Uh, log male spectrogram is corresponding to the time of the log male frequency representation, which was obtained in computation. MFCC computation for the plot of log male spectrogram of the different emotion data set. We observed the MFC features, and the log male spectrogram can be represented as an image, and image can be fed to a deep learning technique such as CNN network and RNN network to classify the emotion. Then the fear tracks are the wave plot between time and frequency, uh, as we seen in our presentation slide. And there are the happy track. At the 2.5 position, the frequency is increases as shown and above shown in our presentation slide. Then we can compare the male and female voice. It is a graph between the time and frequency. After comparing the both and male and female voice tracks, we seen that the graph is mainly general, having the low speech or voice, while the male having the low speech voice, while the female having the high pitch voice. Rather, is often to associated with the male voice, while the female voice is associated with the gently articulation main that tends to use fully pitch range during the speech. while the female having the verb pitch range during the speech are more likely to raise the volume for emphasis, while the women are likely to raise the pitch for the same purpose. Then let's move towards the data augmentation part. Having the normal audio between frequency and time. uh, at the position of 2.5, the frequency has been increases, having the normal audio position. Then in stage audio, uh, state audio, the state audio, the the main function of an state audio is to improve the model performance. We can show at the position of 3.5, we can improve the model performance. uh, then let's move towards the confusion matrix. After the data augmentation, we implement the confusion matrix. We compare the actual label and predicted label. We can see the female claim is going too high. Uh, this is our accuracy plot after implementing after implementing training and testing loss. See that the testing loss is more than uh, the below figure shows the training and testing loss or dataset. As the graph of say the both training and testing error reduce the number of epochs to the training model increases from the above plot. We can also we can also infer that infer that the number of the suitable epochs is around the 200, and the accuracy of the test data remain constant after 200 epochs. Post model, the training we must be dissipate our test emotion with a 75% average, and accuracy is 80% at the most. 80% accuracy at the most accuracy. The following table display our distribution, which actually values the uh, predicted value. And then let's move toward the challenges where we making our model. The large speech data sets to handle. Antoning audio recording is challenging. Should be labeled in single word, sentence, or whole conversion. How many emotions should be defined to recognize? It is not easy to task to convert the speech to emotion. Emotion are subject to people will interpret it differentially. It is hard to define the notation of emotions. Then let's move towards the conclusion part. Through this project, we show how we can be leverage machine learning to the obtain the underlying the emotions from speech audio data, and some insight on the human expression of the human through the voice. This system can be employed in the varieties of setup like a call center, complaint, or marketing, or in voice band virtual assistant, or chatbot in linguistic research, etc. Codes which are deployed are in GitHub repository. It was such amazing and interesting project. We learn a lot from this. Thank you.